Hello, Math Knights. This is Mr. Martiello, and I'm here with a real world problem for you. Are you ready? You see, um, you lost mom's charger for the third time, and she would like you to pay her back the $36 for you to replace that phone charger. You don't have any money right now, but good news. You have found a job walking dogs in the neighborhood, and you're going to make $12 a day. Now, you can't pay mom back all at one time. So here's your task. You have to come up with a payment plan. And that payment plan can happen a number of different ways. You have to pay her back $36. And you're making up to $12 a day. But you don't have to pay mom back all at one time, of course. That is, if her phone is on a really low battery, you may want to pay her back and she may not be very happy. Or maybe she's a little more forgiving and she's allowing you to pay her back a little bit over time so you still have some money in your pocket. That's up to you. Your job is to figure out, what does that payment plan look like? I would like you to create some type of model, an equation to figure out the math, and then you need to figure out how you're going to explain that payment plan back to mom. Let's take a look at this problem. I'm going to give you a few minutes to solve this on your own, and then on the other side of your problem solving, I'm going to give you some strategies on how to solve this too. All right? I look forward to seeing what you could come up with. Good luck, Math Knights. I hope you enjoyed solving that problem. And I hope you found a way that works for both you and for mom. So let's take a look at the one way I used a model to show my thinking. In this model, I used a number line. And I love this app. It is from the Math Learning Center. And if you want to use this app to show your thinking, you could use the bit.ly link right here. Type that right into your address bar and it'll take you to the number line tool. You see, I created a number line that goes all the way up to 36 because that's how much I need to pay mom back. Each of the jumps is 6. So one jump represents $6. I also created 6 jumps altogether. So if I have 6 in each jump and I jump 6 times, it eventually gets me to 36, which is the same thing as saying 6 times 6 is 36. If this model works for you and your brain thinks this way, use the bit.ly link right here, type it in, and create your own way. Create the number line that represents your payment plan. Here's a second way to think about the problem. I used equal groups on this app. Again, this is from the Math Learning Center. And in this app, I used equal groups. I took one group, and in that one group, I put 6 chips representing the $6. In the other groups, I created groups of 6, and I have 6 groups all together. Again, the 6 chips in the circle represent the number of dollars I'm paying mom back, and each of the groups represents the number of days it's going to take to pay mom back until I get to 36. If you like this app and you like this model, take a look at the bit.ly link here, type that into your address bar, and you too can show how your payment plan looks using equal groups. Here's another way. This is an area model. And I used another app from the Math Learning Center using pattern blocks to create an area model. My area model shows that I have 6 blocks in each group. That's the number of dollars I need to pay mom back per day. And then I have 6 groups of 6 to show how many days it's going to take to pay mom back until I get her the $36. If your brain thinks the same way, You too can utilize this tool from the Math Learning Center using the pattern blocks to create an area model. Just take a look at the bit.ly link that's here on the screen. Type that into your address bar, and you too can use an area model to show what your plan might look like. So there you have it, ladies and gentlemen. We had a problem. We needed to pay mom back the money for the charger. We needed to pay her back $36, but there were a number of different ways we could have paid her back even though we were making $12 per day. I hope you enjoyed solving this problem. I hope you enjoyed solving it the way that you felt it needed to be solved. And I hope you enjoyed using the tools that we have right here on the Math Learning Center to show your thinking. And even if you're not able to access those tools, you can still utilize any one of these models using paper and pencil. That's just as good. I wish you well, Math Knights, as you continue your problem solving, and I want you to take care. Hello, Math Knights. This is Ron Martiello. I have this video that I presented to our Math Knights students, and I want to share my thought process in creating this task so that you understand the connection between the math task and the standards of mathematical practice. So let's take a look at the problem. The problem is a real-world problem, and I think we've all been there, losing something that mom or dad really needed. The student has lost their mom's phone charger for the third time, and mom is asking the child to pay them back the $36 to replace it. So they don't have any money right now, but they can make $12 a day walking dogs in the neighborhood. Their job is to come up with their own plan, and we could make this a very closed problem where it's like, well, how many days, if you make $12, how many days is it going to take you to pay mom back? But I'd rather open it up, and 36 is a great number because it has a lot of different factors that kids can work with. And students can kind of come up with their own preference on how to pay mom back. They know their moms, and maybe they think they need to pay mom back right away because she might be quite upset, or mom might be a little more forgiving and allow them to pay her back a little bit at a time. But that's where students get to make a choice and have some preference in the math problem solving process. Let's go over the mathematical practices. Math practice number 1, making sense of problems and persevering through them. This situation type is equal groups. And by identifying that it's equal groups, students can make sense of the problem. They can identify whether they have to find the total, the number in each group, or the number of groups. In this case, it's open, so both the number of groups and the numbers in each group are unknown. And students can, again, use that flexible thinking to figure out which they prefer. In standard mathematical practice number 2, students are reasoning quantitatively and abstractly. And let me explain. So they have to see the problem in context. They have to reason through the quantities. And those would be the number of days and the number of dollars involved in the problem. Once they figure out what the problem is saying quantitatively, then they have to reason abstractly. They have to go to the math. They have to draw their models. They have to write their equations and figure out what possible solutions there may be. And then they have to come back and reason quantitatively so that they can explain to mom how they're going to pay her back. SMP number 2. In SMP number 3, students are creating a viable argument. They're creating an argument based off of their background and their understanding of how fast they need to pay mom back. And if they might need to use a little more flexibility so that they can keep a little more money for themselves as they work through their week. This is a way for students to create that viable argument, and by giving them the room in the problem and not just coming up with one solution, they can create that argument. SMP number 4, we are definitely working through models. The equal groups model, the area model, the number line model, all of those models are great ways for students to show their thinking. In SMP number 5, students are using tools strategically. We're giving them the option of using the area model, the number line, the equal groups, or any other way they may feel they can solve the problem and show their reasoning. I'm going to stop right there because that's a lot of mathematical practices right there in that one problem. And this is the level of thought that I always like to try to take when I'm creating a task. How many ways can I get kids to think about the math? And by incorporating a number of different mathematical practices, we can create those richer tasks. I wish you well as you continue to create those rich math tasks for your students. Take care.